Hello, my dear children. Welcome to the mathematics class. Today, we are going to discuss a new concept. In the previous exercise, that is, in the exercise 5.5, we have discussed logarithmic differentiation. I hope you have learnt well. Isn't it, my dear children? Right. Now come to the chapter continuity and differentiability. Exercise 5.6. Next exercise. For this exercise, in this exercise, we are discussing a new point, a new way of differentiation. So this is concepts. Only one point is there. Let us discuss. Let us start. Are you ready to listen the class, my dear children? Right. Derivatives of functions in parametric form. In this exercise, we are finding the functions in the parametric form. What is meant by parametric form of a function? Let us discuss first. Okay, my dear children. Sometimes the relation between two variables is neither explicit nor implicit. In our mind, variables, what are the two variables? Generally x and y. The relationship between the two variables means x and y. Between x and y, that relation is neither explicit nor implicit. Okay, my children. Explicit means we can write x is equal to function of y, or y is equal to RHS a function of x. That is called explicit. Implicit means we can't write x is equal to function of y or y is equal to function of x. Okay, my children. In exercise 5.3, we have discussed implicit functions. We can't write the function as a y is equal to in terms of x. Okay, my children. But some link of a third variable with each of the two variables separately establishes a relation between the first two variables. Here, a third variable will be introduced. That third variable link the first two variables. Okay, my dear children. In such a situation, we say that the relation between them is expressed via a third variable. The third variable is called a parameter. So here we introduce a new variable that is called parameter. That third variable is called parameter. We link the two variables x and y with a third variable parameter. Okay, my children, understood this point? Right. More precisely, a relation expressed between two variables x and y. Previously I told you variables means in this chapter x and y. So between x and y in the form x is equal to f of t and y is equal to g of t. So here the variable x is defined in the function of variable t. Similarly, y is defined as a function of variable t. Understood the point, my dear children? Right. Is said to be parametric form. These two equations together called parametric form or parametric equations with t as a parameter. Understood this point, my dear children? Right. In order to find derivative of function in such a form, means if you want to find dy by dx, they will give parametric equations, parametric form like this. In such case, if you want to find dy by dx, we obtain dy by dx. We get dy by dx by the following formula. We use this formula to find dy by dx. Dy by dx is equal to dy by dt by dx by dt, because here x is the variable x is defined in the function of t. So we had to differentiate this variable x with respect to t, not with respect to x or not with respect to y. Similarly, here variable y is defined in the function of t. So we differentiate this equation with respect to t. Then here we get dx by dt. Here we get dy by dt. Then dy by dx is equal to dy by dt by dx by dt. This is also a chain rule. Understood this point, my dear children? This is only the important point in this exercise. Okay, my dear children, got it? Right. Let us take an example as well as the question in the exercise 5.6 to understand this concept well. Okay, my dear children, to make this concept very clear to you, I am taking an example, or directly I am taking the question from the exercise 5.6. See page number 181. Page number 181, question number 1. If x and y are connected by the equations x is equal to 2at square, y is equal to a t power 4, without eliminating the parameter, find dy by dx. See here, see the equations, my dear children. X is equal to 2at square, y is equal to 2at power 4. Here variables are x and y, but both variables are connected with the variable. Can you find what is the variable here? T. Yes, not at, not a, not a. A is always considered as a constant. Okay, my dear children. So the two variables x and y are connected with the variable t. Here x is defined in the variable t, and y is also a function of the variable t. Understood, my dear children? Right. Now, without eliminating these two variables in the t, we have to find dy by dx. So, first I wrote here x is equal to 2at square, y is equal to at power 4. I have done simultaneously, but you can do this part separately. You can find dx by dt separately, and you can find dy by dt separately. First find dy by dt and later dx by dt later, like this. Okay, understood, my dear children? So differentiating with respect to t. Understood this sentence, my dear children? Here the variable x is defined in the function of t. So we are differentiating this variable x with respect to t. So this implies, what is the differential operator here? D by dt, not d by dx. Remember this point, my dear children. Here the differential operator is d by dt, because we are differentiating the functions on both sides with respect to t. Understood this point, my dear children? Right. So I wrote this step. D by dt of x is equal to d by dt of 2at square. On both sides, I wrote the differential operator. Understood this step, my dear children? Right. This implies d by dt of x means dx by dt is equal to, here 2a is a numerical coefficient. We can write it outside of the differential operator. So I wrote here 2a outside the differential operator. Before the differential operator, I wrote the numerical coefficient 2a. Then what is left here? T square. So d by dt of t square. Understood this step, my dear children? Right. So I wrote the reason also, because d by dt of x is equal to dx by dt. Now come to this part. Okay, my dear children. Y is equal to a t power 4. Second equation. Here also we are differentiating with respect to t, not with respect to x. Remember this point, my dear children. Generally here y is there, so we you assume that you think that we have to differentiate with respect to x. No, not at all, because here the variable y is defined in the function of t. So we have to differentiate on both sides with respect to t only. Remember this point, my dear children. Right. So what is the differential operator here? D by dt. Isn't it or not? Yes. So d by dt of y is equal to d by dt of a t power 4. I wrote the differential operator d by dt on both sides. That's all. That only I wrote here. Understood this step, my children? Right. This implies d by dt of y means dy by dt. Understood this LHS part, my children? Right. Is equal to, come to the RHS part. Here a t power 4 is there. Here a is a numerical coefficient. So we can write it before the differential operator. So I wrote a before the differential operator. We take out that one numerical coefficient from the differential operator. So I wrote here a into d by dt of what is left here, t power 4. Understood this part in RHS, my dear children? Right. Because d by dt of y is equal to dy by dt. Understood this step, my dear children? Right. Now come to this part. Here dx by dt is equal to 2a into d by dt of t square. Okay, my dear children. So I wrote LHS part as it is equal to, I wrote 2a also as it is. Come to this part. In RHS, come to this part. How it is? D by dx of x power n. It is in the form of d by dx of x power n. In the place of x, here t is there. D by dx of x power n. It is in the form of d by dx of x power n. What is the formula? D by dx of x power n formula. N into x power n minus 1. Here x means t and n means 2. Understood this point, my dear children? Right. So 2 into t power 2 minus 1. What will you get here in the exponent? 1 only. So I am not writing t power 1. So 2t only. Understood this part, my dear children? Right. Because we used this formula in this step, d by dx of x power n is equal to n into x power n minus 1. Understood this step, my dear children? Right. This implies dx by dt, I wrote LHS part as it is equal to, in RHS, differentiation part is over. We have to simplify the term. What is that? 2 into 2, 4, a into t, at. Understood this RHS part, my dear children? Right. Now come to this side. This side. Here dy by dt is equal to a into d by dt of t power 4. We have to simplify this part only. We write the remaining part as it is in the next step. So in the next step, I wrote LHS part as it is equal to, I wrote this a also as it is. We had to simplify this part. What is the formula? What is the appropriate formula? What is the right formula to find differentiation? It is in the form of d by dx of x power n. Yes, we have to identify which formula is a suitable formula to find the differentiation of the given function. So it is in the form of d by dx of x power n. Understood, my children? Right. So we are using that formula, d by dx of x power n formula. What is the d by dx of x power n formula? N into x power n minus 1. Already we used the same formula here. So a into, here x means t and n means 4. So n means here 4 into t power 4 minus 1. What will you get in the exponent? 3. 4 minus 1 is 3. So I wrote here directly 3. Understood this part, my dear children? Right. Now differentiation part is also over. Now simplification part is left. So in LHS I wrote dy by dt as it is equal to, come to the RHS part. What will you get here? 4at cube. Understood, my dear children? Right. Now we have found dx by dt and dy by dt separately. Understood, my dear children? Right. Now we have to find dy by dx. Actually the question is we have to find dy by dx. So dy by dx is equal to dy by dt by dx by dt. I told you previously at the beginning of the concepts, dy by dx is equal to dy by dt by dx by dt. that is equal to, what is the dy by dt here? 4at cube by what is dx by dt? 4at. Understood this step, my dear children? Right. By simplifying here, 4 gets cancelled, a gets cancelled, t cube by t, what will you get? After simplifying this one, we get t square. Understood, my dear children? Right. Therefore, dy by dx is equal to t square. This is the value of dy by dx. Okay, my dear children? Got it? Right.